And welcome back, students, for yet another lesson in logic gates. Today we're talking about the NOT gate. So, another quick recall. We've looked at both and or logic gates. Now we're going to look at the NOT or the inverter gate. It's called an inverter because it literally inverts the state, so it's true, it becomes false, and vice versa. So, as I just mentioned, if it's true, it becomes false. If it's false, it becomes true. That's the whole purpose of a NOT logic gate, is to switch the state. So, if I have a logic gate with a state of 0, and I apply a NOT logic gate to it, I'm going to get an output of 1. If I have an output state of 1, or an input, excuse me, I will get an output state of 0. It's pretty easy. It just literally flips it. So if it's true, it becomes false. False becomes true. And we can look at that in the truth table. And of course, it's just as I just mentioned. We replaced all the zeros with false and all the ones with true. Here's our logic gate representation. Alright, if you notice, there's no B here because we're just simply looking at one state right now. Right, here's our logic gate, and of course you know the A state is changed to that of Q because what this little dot right here represents when we're looking at logic gates, that means to invert the state. So it changes it from being true to being false, or from being false to being true. Now you can use NOT after an AND or an OR statement, and that will change the state of the output. So to find the final output, first we're going to calculate the AND or the OR gate. And then once we find out that answer, whether it's true or false, we would then invert the answer to false or true. Now eventually we're going to discuss NAND and NOR logic gates, which accomplish the same things what I just mentioned here, except the advantage of that it's all done in one single logic gate. So you don't have to write a logic gate for a AND statement and then write a logic gate for an OR statement. So here's an example. Let's test the number -7. And we're going to start with testing if a number is less than 0. So, since -7 is less than 0, this will be true. However, since we're applying a NOT logic gate, we would need to invert the state. Therefore, our final answer is not true, but false. So our logic gate would actually return the value false. And that concludes our notes, folks. Until next time.